All right, how's it going? This is going to be part 2 of our lesson on chapter 4.6. So what we want to do is we want to describe the similarity transformation that maps the pre-image to the image. Okay. So remember, the pre-image is going to be the figure with just capital letters, and the image is going to be the figure that has the little apostrophes or the tick marks next to the letters, the prime symbols. All right, so once again, we're talking about similarity transformations. These are going to preserve the shape, but change the size. And obviously, we can see that the size is going to change here in all 3 of these figures. And the most important thing to remember is that to change a size, we need to use a dilation. So you need to use dilations to change a size, and then we might need to use some other types of transformations like reflections, rotations, or translations to get things to line up perfectly. All right, so let's look at question number 4. Okay, so we have 3 points. Let's start with point M. The coordinates are 0, 4, and then point N has coordinates 0, let's see, 2, 3, 4, 5, 6. And then point L has coordinates 6, 6. Right. Now, as I'm looking at these 2 triangles, I see that this is much bigger, and to map it over here, I need to make it smaller. Okay. Now, the question is, how much smaller is this triangle compared to this one? Okay. And I can see that the left side here is 1 unit long, and the left side here is 2 units long, right? So I can see that this is half the size, okay? So what I need to do is I need to use a scale factor of 1/2, right? To basically shrink or reduce this down to half its size. So let's use a scale factor of 1/2. In other words, I'm going to multiply all these original coordinates by 1/2. So now this will become, let's call it M prime, I guess. It'd be 0, 2. N prime would be 0, 3. And L prime would be 3, 3. Okay, so just kind of cut everything in half. Okay, let's graph this one. 0, 2 would be right there. 0, 3 would be right there, and 3, 3 would be right there. Okay. So now I've got it to be the right size, but it's not in the right location. I actually need to move it over here. Okay, and so I know that's going to involve, let's see, moving it, let's see, 1, 2, 3, 4 spaces to the left, sorry, to the right, and then 1 space down. Okay, so now what I need to do is I need a rule that says add 4 to the x coordinate and subtract 1 from the y coordinate. Okay. Or we can just say, if we can describe it in words, shift 4 units right and 1 unit down. Okay. And then we would get it to line up perfectly with this final image here. Right, let's look at question number 5. Okay, so here's the image, the pre-image, and then here's the final image. Okay, so let's go ahead and write the coordinates of the pre-image first. So point A is -3, 3. Point B is -3, 1. And point C is -1, 1. So to map this triangle onto the final image, I need to enlarge it. Okay, I need to make this bigger to match the size here. Okay, the question is how much bigger? Well, let's just look at one of the side lengths. Okay, so if I look at the bottom side here, that's 2 units long, and if I look at the bottom side over here, that's 4 units long. Okay, so I need to make this triangle 2 times bigger to match the size of the other one. So what we're going to do is we're going to use a scale factor of 2. Okay. Multiply everything by 2. Right, so this is going to be -6, 6. This is going to become -6, 2. And this is going to become -2, 2. Right, I just multiplied all 6 of these values by +2. All right, so let's graph this now. -6, 6 is right there. -6, 2 is right there. And -2, 2 is right there. Okay, so now my red triangle, which is kind of this middle stage, matches the size of my final triangle, okay, but it's not in the right location. Okay? But I can see that all I need to do is reflect it over the y-axis, right? Just kind of flip it over there, right? And then it would match up. Okay. So the last thing I need to do is reflect across the y-axis, and once I reflect it over, right, then it would match up perfectly. Let's just draw a picture here, showing the reflection. Here's our last one. Okay, so we have a quadrilateral, QRST. This is the pre-image, and then the one with all the primes or the apostrophes, that's the final image. Okay. So we need to reduce the size. We need to shrink this down, okay, to match the size here, and then probably do something else afterwards. Okay, so we have Q 0, 0, R 4, 3. S 4, 6, and T, which is 0, 3. All right, so let's figure out how much we need to shrink this down by. Okay. So I could see here that I can measure the length of this side here. It's 1 unit. I can't really measure this because it's diagonal, but I can measure this one, and that one's 3 units there. Okay. So our pre-image has a measurement of 3, and our final image has a measurement of 1. So we need to reduce this by 1/3 to make this smaller. Yeah, 1/3 is small. So we're going to use a scale factor of 1/3. Is that right? Okay, well, let's see what happens. Okay, so if I multiply these by 1/3, well, it's just 0, 0 still. If I multiply those by 1/3, it's going to be 4/3 and 1. If I multiply that by 1/3, it's going to be 4/3 and 2. If I multiply that by 1/3, it's going to be 0 and 1. Okay. All right, let's graph this. 0, 0, 4/3, 1. Four-thirds, 2. You know, yeah, okay. And then 0, 1. And then at this point, it looks like it's the right size, but I think what we need to do now is we need to rotate it, right, to make it match up here. If I had piece of tracing paper. So if I do a quarter turn, right, then I can get, oops, doesn't quite line up perfectly, but I can get it pretty close. So the last thing to do here would be to rotate 90 degrees counterclockwise. Okay. All right.